Hello, there used to be a hype about graphite thermal pads, and that hype died down quite quickly. And the reason for that is, well, we'll find out today. So I'm going to compare graphite thermal pads against a conventional thermal paste. I will be using something by Thermal Grizzly. Now they make an amazing paste already, a range of products actually. The adversary on the other hand is the MX4 Arctic. I can't be bothered to take out the tube, but you know very well what it is. I have made at least 4 videos about that thermal paste. So before I jump into the results, I will show you exactly what the graphite pad does compared to conventional thermal paste. So let's see what my hands can come up with. Alright, I'll try to make it as snappy as I possibly can. Therefore, we have our CPU. The CPU looks pretty flat. The CPU is not actually flat because on a microscopic level, if you zoom in very much, you will see that the surface is actually very jagged. Same thing with the heatsink. On a microscopic level, it looks very jagged. When two jagged surfaces come together, you do not get a good contact between them. What you get instead is this, air bubbles. You see these things? These are air bubbles. The problem with air bubbles is that air is a terrible conductor of heat, and therefore it will store that heat in it, right? So what happens is the heat does not get transferred to the heatsink efficiently enough, and therefore heat starts to build up on the CPU, which will then start to throttle, and then you experience reduced performance. The solution to this is simply to replace the air with something else, right? Something that has better thermal conductivity, and that is our trusty thermal paste. The thermal paste tries to completely replace the air and therefore provide a mean to transfer the heat effectively between the two surfaces. A good thermal paste will have between 8 and 12 watts meter Kelvin. This is not millikelvin, it's meter Kelvin. I should probably put a dot here of thermal conductivity. Now onto the paste. Not the paste, but onto the actual graphite thermal pad. Now, the manufacturer says that thermal conductivity is 62.5 watts per meter Kelvin. I can show you that right here. And this would be true if the two layers made absolutely perfect contact with the thermal pad. Think about it. If the thermal conductivity was this high all the time, then the paste here would not have a reason to exist at all. Therefore, when you press these two surfaces against each other, you get some decent contact points, right? But you also get these tiny air bubbles still, and those air bubbles will cause you problems later down the line because the same problem as before. Air bubbles become quite hot and impede a correct transfer of heat between the CPU here and the heatsink over here. The advantage of a graphite thermal pad is the fact that the heat can be transferred insanely fast within the layer itself. So if, for example, this heat here can be transferred over here very quickly and can be expelled that way. The problem still remains is that those air bubbles are still there. Now this is me trying to come up with an explanation as to why this thing doesn't provide full fat 62.5 watts per meter Kelvin in terms of performance when compared to the thermal paste. And yeah, I think that's because air bubbles are still left there. So you need a very good mounting pressure in order to get even just similar results at high powers. So let's just jump into the actual results of my findings after using the thermal pad for a little bit. Alright, so it's time to tell you the results, and the best way to do so is to use a miniature version of me on the screen. Here is the first screenshot. So let's start with this. So this is with the graphite pad, and I have run a couple of Cinnabon tests to see how the actual paste fares. And you can see from the initial temperatures that temperatures do skyrocket when the CPU is pulling a certain amount of watts. And up here, oh great, I don't have to use my hand, I can use this mouse. Okay, up here you can see that the CPU is actually frosting a little bit. If we move on to the paste instead, we see slightly better results. So we can see that there is a massive peak here. Massive is a relative term because it is still below 90 or just above 90, yeah, just above 90 as far as I can see. And yeah, this is because the fans didn't actually quite kick in. And I've done one in non-performance mode, which is here, and you can tell because the CPU was then pulling 54 watts, whereas here it's pulling the full 60 watts that you would expect in performance mode. And yeah, you can see that the temperature actually went down, and this is because I've run max fans on this particular run, whereas here it was auto fans. And you can see that the clock speeds are much better compared to before. Here it's throttling, here it's definitely not throttling, and here it was because of the fans not turning on. So this is actually an issue on the laptop that I have. The fans turn on a bit too late when the temperature starts to skyrocket when you're doing some kind of test or you're just gaming. Talking about gaming, actually, we can move on to actual gaming session. So I've run a gaming session using the actual Graphite pad. I've run it with the boost enabled for a little bit, then I decided, you know what, I want to see what it looks like when the boost is disabled. And you can see with the temperatures don't actually look too bad, but then if you look below, you can see the GPU is hardly pulling all of its available, you know, watts, and the CPU is doing about 20 watts being pulled here, and that's fine. Then with the boost disabled, you can see the temperatures are actually really nice, and tell you what, the FPS difference is really not that big as long as the GPU is still doing what it's doing, if the game is a GPU intensive game. And if I had the actual load, you'd see that the GPU is being used a lot more than the CPU. With the thermal paste, of course, results will always be better. This is again, I think this was Genshin Impact, and temperatures are really nice. Full 80 watts is not quite being reached, it's almost there, more or less. Still the usual 20 watts being pulled. And then I think this is Apex Legends for a little bit, yeah. And the temperatures, you can see, they're okay, they're not too bad. So what surprised me though is that at low power consumption, this is about 10 watts being pulled here, the thermal pad is actually doing amazingly well, or at least as good as the thermal paste. So you can actually infer a couple of things from that, right? What you can infer is that the thermal pad is actually exceptional in situations where there is a component with low power, you know, consumption. So the lower the power consumption, the better it will fare compared to you know, its counterpart at a higher TDP. So what I suggest is, if you ever consider getting one of these graphite thermal pads, is to make sure that the component you're about to cool with that thing has low enough wattage. So I guess in ultrabooks maybe the components will not be consuming too much power. I think some CPUs go up to 15, maybe 25 watts being pulled at full capacity. So in those situations, maybe something like a graphite thermal pad would make sense if you hate repasting your laptop. But if you don't, then a thermal paste is a much better solution. Having said that, remember what I said about the actual mounting pressure between the two layers. So talking about mounting pressure, you can see right over here. I think you'll better see here, this is slightly raised, and this is after I've removed it from the CPU. Don't worry, this thing was applied on the GPU too. It just fell off when taking the picture. This tells you something though. Here you had, I'm not sure if you can see this arc, you had a very good contact here, okay, between the CPU and the heatsink, whereas here you had a fairly decent contact, but not so much, because as you can see, it came off quite easily after being removed. What that means is that there isn't a very even distribution of pressure. Not sure if that makes sense, but the pressure is not evenly distributed along the surface or throughout the surface. So you get some bits that are squashed a bit harder than other bits. Overall though, you have a fairly decent application. However, if you want the best possible application, you look into putting as much pressure as you can. I don't recommend it because put too much pressure, that may damage components. I know some people who absolutely go berserk on actually putting pressure, but personally I wouldn't do it. I don't think it's worth the effort, even for just trying to sort of bend the heatsink so that this area here is slightly more depressed than others, so it would make a good contact. It's not worth the effort, and that would counteract any benefit of the thermal pad, because graphite thermal pads, the promise of graphite thermal pads, that once you put it in, you never have to take it out again. And you know, that is a good promise. However, I would only suggest using these kind of things in very low powered components, whereas just keep using good thermal paste for anything else. So yeah, as a bonus clip, I will show you this. These are Cinebench scores, and this is a 4800H that I'm running here. That's a pretty decent score for a 4800H, I'll say. This is Cinebench R23, and this was in performance mode, but with the fans off. What? No, with the fans in auto mode. Whereas this one is with the fans in with the max fans on, and therefore you get almost 11,300 points, which in my head is bonkers for a 4800H, pulling 60 watts. So yeah, it's pretty good stuff. Conclusive remarks: the promise was that it would, you know, it would take up the entire thermal industry. It didn't. That wasn't the promise. The promise was that this would allow you to use something else instead of thermal paste that you don't have to work with all the time. And from experience, I can tell you that changing thermal paste is really not that big of a deal. It can be done in a few minutes if you have enough experience. So are they worth getting? Honestly, I don't know. If you hate cleaning up the mess that the thermal paste left, then at low power components, I think it's a viable option. For anything else, just use the paste. Yeah. So thank you very much for watching this video. Don't know why you're still here. Just go and do your own stuff.